Welcome to our webinar today. We're going to be talking about evaluation of chemical risk using safety data sheets. So really appreciate that everybody is able to join us. And we're going to go ahead and jump right in and get started. So I want to stop for just a second and I'll let you know, my name is Becky Anderson. I've been assisting schools for about the last 25, 30 years with chemical risk mitigation. I was also a volunteer firefighter for a little while, and I've been a bench chemist in industry as well. So I've got quite a bit of science background and experience. Unfortunately, I think I've read 10 million plus safety data sheets in my career. So this is something that I use regularly, and I'm hoping to share some strategies with you today so that they're a little easier for you to navigate as well. Before we get started, I want to take a quick minute to thank EPA Region 1. They're the funding source for us to be able to offer these webinars to you. And I want to thank Vicki Davis of the Upper Valley Lake Sunapee Regional Planning Commission. Vicki is the genius grant writer that has gone after this funding and been successful in achieving it. So, and then finally, a lot of the resources that will eventually be available to you on either the hazardous materials consulting website, which is my business, my consulting business. Many of those are from Dave Waddell. He's my mentor in the industry. He's now retired, but he also assisted with mitigation of chemical risk in schools for many years. So I just wanted to shout out to Dave, an appreciation as well. Finally, the goals for this webinar are really to help you understand the risk of chemicals in your school, not just in science labs, but also in art classrooms, facilities, industrial tech, to assess those, to learn how to evaluate them, to learn how to develop kind of a sense of how much risk is present, and then to work to minimize that risk. So are there some strategies? Are there alternatives? Are there different things that we can do to minimize that risk in schools? So that's what we're working towards. And all of these webinars, we have a series of 12 of them. All of these webinars will eventually be on the Hazardous Materials Consulting website, so you'll be able to reference back to them. I'm not quite there yet. I'm still working on it, so bear with me on that. All right. Couple of tips and tricks for today since we are on the webinar. If you have questions, please submit those in the question and answer box. And I'll try to pay attention to that while we're going through, but I might just hold off and answer those questions until the end. Also, keep in mind, we do allow for extra time at the end. So if you have any questions, even if they're not about today's seminar, if you've got something else, please go ahead and ask them, and I'll do the best I can to get you some answers so that we can assist you. The chat box is closed. There is closed captioning available if that would help you. The raise hand is disabled at this point because we have so many people on. And if you're having trouble with audio or anything like that, the lower left has an audio and a sound, kind of a troubleshoot button. So see if that will help you. All right, topics for today. First, we're going to do a quick review. We've recognized and we've assessed, we've discussed a lot in the first couple of seminars or webinars about legacy chemicals, what they are, helping you to identify whether or not you have them, and then especially calling out those ones that are really dangerous to make sure that you leave them in place. Don't mess with them until we have a plan. We've also minimized risk by identifying chemicals that we just need to get rid of because of age, quantity, integrity of the container, or risk exceeding the utility of that chemical. And then we talked last time about how are we going to store the chemicals that we are going to keep by chemical class so that we can store them most safely. We've talked about different components of a chemical hygiene plan. And the next webinar that we go through will be buttoning up how do we get to the point where we're ready to write our chemical hygiene plan for our facility. Today's topic, what we're going to talk about is we're going to do a quick review of OSHA's, called the Hazard Communication Standard, or a lot of people call it HAZCOM or GHS. There's a whole bunch of different names for it. We're going to call it OSHA's HAZCOM standard, and I'll go through the OSHA citation so that you know exactly what I'm talking about. We're going to then talk about and move into specific sections of safety data sheets and how they can be most useful for you, where you can glean the most information to make your own decisions about whether or not they're too risky to have in your school, in your facility. And then we're going to also talk about some of the toxicology data. So I'll give you some of the abbreviations that are used And I'm going to use kind of a down and dirty strategy, a real quick evaluation strategy. I'll teach you how to do that so that when you're looking at those safety data sheets, the 16 sections of them that usually end up being about 20 pages of text, they can get very overwhelming. So I'm going to tell you some strategies so that you don't get quite so overwhelmed, but you still glean the best information from those. Then we're going to go through some resources and support at the end and some steps you can take to prepare until we have our next seminar, and then we'll have time for question and answers after that. All right? Okay, let's see. I'm going to go ahead and turn off my video. All right, and we still have the screen and everything, right, Rosa?
Yes, we do.
Okay, fantastic. All right. Final housekeeping, please make sure that if you do have questions, that you use the question and answer box. Also in the question and answer box, we're going to drop in a safety data sheet that we'll be using today as a reference material. We're going to use the Sigma Aldrich methanol safety data sheet. Those are the sections that we're going to cover and talk about. That's a pretty common chemical that we see in a lot of schools. Okay. All right, so we've talked about legacy chemicals. You also have, if you're a science teacher and you've been joining us for all the other webinars, you have, I'm going to try to drop in that. Vicki, if you could drop in that methanol.
I did. It's in the question and answer, or I'm sorry, it's in the chat box for everyone.
Yeah, okay, and everybody can get it out of the chat? Everybody can access it? Okay, fantastic. Sorry about that. All right, so we talked about legacy chemicals. Also, if you're a science teacher, we asked you to map the safety equipment in your classroom. That's one of the key components of a chemical hygiene plan. We've also asked you to identify chemicals that you want to keep and develop an inventory of those chemicals. That inventory of chemicals is really critical. It's a key part of your chemical hygiene plan. It's also really important for you to be able to pass along to your administration so that they can, and also your safety committee, so they can evaluate what chemicals you're using and make sure that the level of risk does align with what we need to have in the different schools. We've also prepared you for dangerous situations by writing concise emergency response plans. Before we talked about getting rid of or moving chemicals around, we talked about make sure that you have a plan in place for if something happens, like a container, the bottom falls out of it, or you end up with a spill, make sure that you have a good spill kit nearby that has useful tools in it. Those are the things we've covered in the prior webinars. So we have a lot of the chemical hygiene plan components completed. And again, we're going to talk more about that and button that up next semester or next webinar. All right, so let's go ahead and jump into OSHA's hazard communication. So the first thing is OSHA's hazard communication can be found in the Code of Federal Regulations. It's in the 29th chapter of the Code of Federal Regulations. And the citation that you want to look for is 1910.1200. And if you simply copy that and put it in Google, it'll bring you right to that code section. Okay, we have electronic access now to all of those code sections, which makes it really nice. Previously, we referred to this as right to know, and we referred to those information sheets as material safety data sheets. In 2016, a lot of that changed. We revised or we implemented a new revision of that entire program in 2016, and it now is called or referred to by OSHA as the right to understand. So you have the right to understand the hazards of the chemicals that you're working with in your job site. It also communicates risk using safety data sheets instead of material safety data sheets. It's kind of funny. I can always tell when I'm talking with somebody who's been around for a while. Inevitably, they'll let slip that material safety data sheet, and I'll go, "Oh yeah, you've been doing this for a while." Because remember, now we've been using safety data sheets since about 2016. Okay, so anytime you do any Google searches, also on any chemicals, you can put in the chemical name. And then make sure you put safety data sheet, not material safety data sheet after it. And that'll bring you to the most recent copies. The intent of this regulation entirely is to provide safe information, to provide risk information to anyone working with chemicals so that they can make reasonable, analytically based assessments about whether or not a chemical is too risky for them to have on site. So for the next few slides, we're going to talk about how to meet the program requirements. And I put on the bottom of this slide that even if you're not subject to OSHA, understanding this chemical risk is critical for your health and that of your students. Now, the interesting thing is I kind of dug into that a little bit, and I'm going to just address a couple of things real quick. First of all, Vermont, you are an OSHA state. So anybody that's listening from Vermont, you are subject to this automatically. If you're from Iowa, you are subject to this. Iowa is also an OSHA state. Found out a really interesting thing about New Hampshire. We're going to talk a little more about this next webinar as well. But New Hampshire does not have a state OSHA program. They do, however, have a number of safety requirements that fall under the Department of Labor. And teachers in New Hampshire are considered public employees. They do fall under the jurisdiction of Department of Labor. And one of the sections that Department of Labor has implemented, has adopted straight out of OSHA, is this hazard communication section. So if you are a teacher or a school employee in New Hampshire, you are under the authority of the Department of Labor, and they cite this specific 29 CFR 1910-1200 hazard communication section as part of their jurisdictional authority. So, you know, I've had some questions from New Hampshire teachers. Well, we don't even have OSHA. Well, you don't directly have OSHA, but you've got Department of Labor, and they're kind of doing the same thing, just a different agency, but they are enforcing the same laws. Now, the requirements for HAZCOM or the HAZCOM standard include chemical classification. We talked about that last time. And what that means is that we segregate chemicals according to their risks. So we put all of the flammables together and we store them in flammable cabinets. We take our acid corrosives and we store them in acid corrosive cabinets. We take our corrosive bases and we store them separately in either a separate base corrosive cabinet or a separate location on a shelf. And then we store things like oxidizers separately as well. So we want to store by chemical classification. Also under this standard is the requirement on safety data sheets, and we'll talk a bit more about that. Labeling is covered. Additionally, any facility that has chemicals on site, if you are collecting safety data sheets, you're also required to have a written hazard communication plan. And what that written HAZCOM plan covers is how you are going to effectively meet all of these requirements. So basically, it can be a pretty short plan that just says, hey, we're collecting our safety data sheets, we're training everybody. And when I talked to the New Hampshire Department of Labor, that is one of the things that the Department of Labor really emphasized, is that all public employees have the right to work in a safe environment where they are provided with training and with the tools to keep them safe. So we've got a question from Katie, and it says, what does this section say about protection of teachers health-wise? It is the Department of Labor does address the health of teachers. And again, what the Department of Labor gentleman that I talked with told me specifically was that there's a lot of emphasis from their program on making sure that we're providing safe environments where public employees are provided training and the tools to be safe. So things like personal protective equipment would be included in that. If you have specific questions about that, please feel free to reach out to me. On my last slide will be my email, and I'm more than happy to provide the contact information for you for that. Okay, other things covered by the HAZCOM program include employee training, an inventory of chemicals on site, and labeled pipes. And that's more targeted at industry. So just to let you know. So we're going to dive into the specifics here quick. First of all, labeling. The GHS or the HAZCOM label, and I'm going to use those interchangeably, so please bear with me on that. A lot of people in industry do. GHS is the same thing as Hazard Communication Program or HAZCOM. Okay, those are all three. Our programs are used interchangeably in industry. For labeling requirements, these are all of the details that have to be on labels. So if you take let's say you take a container of a commercial cleaner and you're going to dilute it 10 to 1 to use in your classroom. You can't just take the piece of duct tape or painter's tape or an Avery label, anything like that, and stick it on that container where you've put the diluted solution in. You have to have all of these components on the labels. So unfortunately, gone are those days where we can just slap a piece of painter's tape on it, write it on in Sharpie. We cannot do that anymore. And I'm going to tell you the reason for that is because people like me come along and they find hundreds and hundreds and hundreds of unlabeled or improperly labeled containers, and we have no idea what they are. I was in a school one time and I found 2-gallon jugs that had duct tape on them and they were labeled bulldog juice. I don't know about you, but I have no idea what bulldog juice is. Okay. So we're going to avoid all of those problems and we're going to go ahead and label them properly. These are all the different components that are required. You've got to put the product name. If underneath that product name, there's what's called a signal word. There's only going to be 2 of them. It's only going to be danger or warning. And danger is the more hazardous. Warning is the less hazardous, but it still tells you that there's some health risks associated with this. All right. So we've got danger and warning. We've got the hazard statements that have to be on there. And the hazard statements, there's some, we're going to look at that methanol safety data sheet here in a few minutes. And there are like 20 hazard statements that would have to be on that label. Then you also have to put down the pictogram. So at a glance, you can identify what the immediate risks are. There are 9 different pictograms that OSHA put into place. And then you also have to have the manufacturer's contact information. Previously, all this did not apply to waste. Now, some of these requirements do also apply to waste. For example, you have to have the name of the waste, you have to have a DOT shipping name, and you have to have the hazards identified. Those are things at a minimum that you have to have. All right. Now, I know that spaces on labels are really small sometimes. So how are you going to fit all of that stuff on there? It can be really overwhelming. This is why our industry folks have gone to, I don't know if you've seen them, but they are the accordion labels where you pull off the top and it stretches out like an accordion. That's why industry has gone to this, to meet these regulations and also to meet some FIFRA or pesticide regulations. But between the two, HAZCOM and FIFRA, we've got all kinds of information that has to be on the label. It can be very overwhelming. So your best strategy is leave your chemicals in their original containers. If it's possible, leave them in their original containers. If you are, and I know this is really tough in science because you're making dilute solutions, and I understand that. Make sure though that you put in place the correct information on the label, because this is one thing that you can be cited for. Now, to avoid that, what you can do is you can do an abbreviated label, but you only use it for 1 day, 1 work day, and then you get rid of the solution. Okay. Best strategy though is to keep chemicals in their original formats or in their original containers. You can also, there's a really nice option or a nice function on Avery. Avery is the manufacturer of a number of different label sizes, and they actually have assistance to build HAZCOM labels. They have templates that are available to you. So you might want to look into that a little bit. Avery has pictograms you can purchase. These are itty bitty little like 1/4 inch, 1/2 inch labels that you can purchase and stick on your containers or your labels as well. All right. But best option, make a small amount, use it for 1 day, put a label on it that meets the criteria for that day, or leave it in its original container. This is what a HAZCOM labeling example should look like. Okay, so it's got the name of the product in the middle. It's got the hazard statement down below it, pictograms on either side. They don't define whether you need to have pictograms on one side or another. They just need to be present. And then the name of the manufacturer along with the phone number. All right. And there I've put on the right just some examples of kind of what the Avery labels look like. So this would be a really good tool for you to have. Most of my industry lab people that are running QMS labs or whatever, they're using the Avery system, and they found it to be very effective. It's a fairly inexpensive way to make your own labels so that you're in compliance. Okay, now the next part of HASCOM that OSHA developed was pictograms. These are pictograms. Under OSHA, there are 9 of them. Most of my colleges and universities now have signs outside of their classroom doors that will identify by pictogram only which of these chemicals are present in their classrooms, if they do have chemicals in their classroom. They also will put these outside of like their chemical stock rooms. There are, I don't want to call them nameplates, but that's kind of what they are, that you can post outside of the door. The other thing I've seen colleges and universities do is put these on a piece of paper, laminate them, and stick them outside of the door so that there's at least a warning of what's present in there. Now, I get a lot of pushback on this, and I can see it both ways. One of the pushbacks is, well, why do we want to show people where our bad stuff is? Yeah, I agree. It's really tough to make that decision. Is it more safe or less safe for students to know the kind of risks that are behind a door? And I don't know the answer, and I don't have a good answer for you on that. I know our emergency response community, if we have to call 911, our emergency responders really, really appreciate this information outside of a door so they know what they're walking into. I can't tell you though, if in a school setting, if it's a plus or a minus. That would be one thing that you'd want to talk with your safety committee about. And I'm going to bring up safety committee quite a bit today, because that's going to lead us into the next webinar about chemical hygiene plans. So one of the things that I'm going to encourage you to do is to start identifying colleagues, key people in your school that should sit on a chemical hygiene or a safety committee, so that some of these things can be decided for your specific school district. All right, I want to talk through these pictograms really quick. Again, there are 9 of them. The first one here that we're looking at is an oxidizer. So that's a chemical that either has oxygen as part of its molecular structure, or it likes to light a lot of things on fire. Oxidizers are a class of chemical that we want to keep separate from everybody else, from all the other chemicals, because they just react with so many things. The next pictogram is flammable. These are chemicals that we want to store in a flam cabinet. And one of the things you'll notice is if you order your chemicals from Sigma or from Flynn Scientific or from I think even Carolina and Ward now indicate they use pictograms on their chemicals. So that will also help you make sure that you're segregating them correctly. Then the last one is exploding bomb. Those are for explosives and organic peroxides. Hopefully you don't even have any of those on site. Not worth it. The next set of pictograms we're going to talk about, first one is skull and crossbones. And the skull and crossbones indicates acute toxicity. So this is stuff that's going to have a really, really big impact with a very small quantity. These are ones that you're going to really have to evaluate. Do you even want anything like this in your school district? It's a lot of times it's just not worth it. The next one is corrosion. And this one really, frankly, kind of irritates me a little bit, because it represents both acids and bases. We had the opportunity in 2016 to fix this and differentiate between acid corrosives and base corrosives, and we didn't do it. And I just think that was silly. So this is actually the pictogram that's going to be used both for strong acids and strong bases. So you're going to have to know and be able to recognize the chemical to determine whether it's an acid or a base. You're going to have to read about it in the safety data sheet or just recognize it from the name. The next one is gas cylinders. We don't typically see a whole lot of those in school districts. Okay, the last 3 pictograms. Health hazard is the next one. And this is an indicator that this is more of a chronic risk. It's carcinogenic, potentially mutagenic, has some reproductive toxicity, or it's an inhalation hazard. The way that I remember this and that I help my folks in industry remember is if you've got an alien bursting out of your chest, it's probably an indication you got a health hazard. It's probably been growing for a while, you got a chronic health hazard. So that's the way we remember that. Next one over is the exclamation mark. Okay, this one I want you to visually, I want you to turn it upside down in your head. Okay, when you turn it upside down in your head, it makes an I. Huh, crazy how that works, huh? Okay, so I means irritant, dermal sensitizer. One of the things, a lot of people just kind of skim over this in safety data sheets, and I want you to really make sure that you're paying adequate attention to this, because sensitizers are those chemicals, kind of like latex gloves. Remember previously we used to have latex gloves all over the place in schools. We had them in hospitals. We had all kinds of latex tubing in hospitals. And then we started figuring out that a lot of people would become sensitized to it. By sensitized, they might start off with just a little itch or a little cough, but then the more exposure they have, the more dangerous this gets. So irritants or sensitizers, we can't predict which students or which teachers are going to react to them. And so anytime we have this exclamation point for sensitizer on a safety data sheet or on a chemical, what I want you to think about in your head is, oh my gosh, okay, well, I don't know who's going to react badly to this, but somebody obviously has, because they had to put that label on it. So turn that upside down, think of it as an irritant sensitizer, and then really think about whether or not that's something that you want in the school. Is there a better choice? Is there a better option? If there's not a better option and it's something you absolutely have to have, then let's make sure that we're minimizing our exposure to it as much as we possibly can. All right, and then the last one is environmental toxicity. The really interesting thing about this is that this is the only symbol that's used globally as part of the hazard communication system globally. So this system, these pictograms are used all throughout the world. The only one that is not in the United States is the one for environmental toxin. It is considered optional. Most of the time, though, what you're going to see from industry is that they're using it anyway. Okay, the next section that we're going to talk about. So we're going to switch to what I think is probably the biggest, most important factor that we have to talk about in hazard communication is safety data sheets and how to read them. Okay, just a second. Tech centers, high schools, we see oxyacetylene, oxygen, and acetylene tanks for welding. Yes, we do see oxyacetylene, and they're usually 2 tanks in a little carrier. And we absolutely need to make sure that those are separated and capped. Those two do not like each other. In fact, that reaction is the important one. So thanks, Heidi, for bringing that up. So this compressed cylinders that we do see are oxyacetylene and welding. Please make sure that you've got those chained in an appropriate carrier and then capped when they're not in use. That's pretty critical. Also, we have a lot of facilities folks that do use small propane tanks, especially if they have a fork truck or something like that. The same thing goes with those propane tanks. Anytime we have compressed gases at all, we want to make sure that they're chained or secured so that they have to stay upright. And we want to make sure there's a cap over the opening valve. Okay. The cap over the opening valve is going to prevent them from popping off. And then we end up with a torpedo. Nobody wants that in a school. Okay. So we're going to go ahead and switch over to safety data sheets. Thanks again, Heidi. I appreciate bringing that up. All right, safety data sheets. Now, some good news for you. You can collect and keep these electronically. OSHA changed their view on that a few years ago. If you are welcome to keep paper copies, I always kind of think it's a good idea to keep paper copies, just because if we end up with, our computer systems go down or we lose data, whatever, electronic certainly isn't always secure. So up-to-date paper copies are also acceptable for you to have on site. You do have to have a complete collection of every chemical that you're using, either electronically or paper, okay? Each SDS or each safety data sheet is going to have 16 sections. All the new ones are going to have 16 sections. If you remember back to before 2016, most of the material safety data sheets were just kind of winged together by companies. There was no consistent formatting. They didn't have consistent information. That's one of the best things that has happened with this new HAZCOM program, is that now the SDSs are consistent. Some of the sections of the HAZCOM, of the safety data sheets, are going to be much more useful than other sections at identifying risk, and so we're going to talk about those. Additionally, if you've come across a safety data sheet, let's say you get some unique chemical in from wherever, and it comes into you and it doesn't have a complete or a robust safety data sheet, one of the things you can do is you can just go out to Google, type in the name of the chemical and safety data sheet, or SDS. And a lot of times options will come up. It's perfectly acceptable for you if you have an incomplete one from the manufacturer, but you want more information, go out and search and find one that is complete. The resource that I use all the time, if I can't find safety data sheets that I think are good quality, is I go to Sigma Aldrich. Now, the downfall here is they only have safety data sheets for single raw chemicals. They don't have any cleaners or blends. And sometimes that's where we see big hangups, is cleaning supplies or blends of chemicals that we use in various, I can think about them in art classrooms. We do also have some industrial tech chemicals that are blends. Sometimes it's hard to find good sources of safety information from those safety data sheets. All right. Now, we're going to go through each of these sections of the safety data sheet, and I'm going to tell you which ones I pay most attention to. So section one's important. It's got the name of the chemical. The big thing that I look for here is, does it have an emergency number, so that if I've got something weird going on, I can call this company and ask specifically for their technical support person. Okay, that's one of the things that I want you to put in your notes. When you call, if you call in to ask questions about a safety data sheet or any of the analytical information that's on it, you want to talk to a technical support person. Okay, a lot of times they will try to feed you into their sales department. And what I have found is that the sales folks just really don't understand the analytics nearly as well as the technical support folks do. So you want to talk with somebody in the technical support area. Also, we're going to look at the other thing that I'm going to look at on here is there's a CAS number. CAS says CAS stands for Chemical Abstract Service. It is a unique identifier for each specific chemical. We've got a question here that says, do SDSs in schools, do you have to have them for sunblock and hand sanitizer? That's one of the really interesting things with this program, is that hazard communication and safety data sheets only apply to commercial products. They do not apply to what are considered consumer products. So no, technically you don't need to have a safety data sheet for sunblock and hand sanitizer or Sharpies or any Elmer's glue. You don't have to have safety data sheets for those. I'm going to tell you though, also, this is a really gray area. And the reason it's a really gray area is because, especially in like the art room, there are things that we can buy commercially and from a consumer perspective in art that we might want to know what the risks are. I will also tell you there's some pretty strong chemicals that are considered to be consumer chemicals. The one that's coming to my mind right now is muriatic acid. I can go to any large box home improvement store and buy a gallon of muriatic acid, which is 37% hydrochloric acid. And technically, that makes it a consumer product, so I shouldn't have to have a safety data sheet for it. However, that's a really high-risk chemical. It's got respiratory hazards, it's a super strong corrosive, and it reacts with a gajillion things. It's not really something that I want on site at a school, and I probably need to know that. If I do have it on site, that's one of those things that I am going to want a safety data sheet for. So even though you're not required to have them for consumer products, sometimes I think it's a good idea for you to try to collect as many as possible. Does that mean if every kid brings in its own sunblock that you have to have a safety data sheet for it? No, I think that's a little overkill. And technically, letter of the law, you don't have to have that. But you might want to have one just to see what's in it in the event that it's listed as a sensitizer. And all of a sudden you've got a kid that breaks out in hives. You might want to know that. So I don't know, that's a tough call, but letter of the law says if you can buy it in a consumer capacity, you don't have to have a safety data sheet for it. There just might be times that you want one. Okay, next thing, section 2, hazards identification. This is the one that I start with. This is the section that's really critical in my opinion. It's going to list for you all the hazard statements. It's going to tell you if a signal word applies to this particular chemical. Signal word being danger or warning. And remember, danger is the worst one, this one. It's also going to have the pictograms on it, and it's going to have all of these hazard statements. So if you look at this one, this is for methanol. Holy smokes. A lot of times we have teachers that will lump methanol in with isopropanol and ethanol. Oh, it's just another alcohol. No big deal. I'm going to tell you, no, after reviewing the safety data sheet, methanol's pretty wicked. What we see here is we've got a signal word of danger. We've got, let's see, several precautionary statements. Not all of them are even listed here because I didn't have room for them. And then what I want you to look at is at the top, there's considered like flammable liquid. It says category 2, acute toxicity category 3. I want you to know that those categories are the opposite of the NFPA diamond. The lower the number, the higher the risk. So category 2 for flammable, the lowest or the highest level of risk is from number 1. These are number 2s. So you have second highest level of risk there. For the toxicity, oral, inhalation, and dermal, these are category 3. So they're about midway for toxicity. Okay, this is not something to mess around with. Okay, section 3 is composition. It's helpful. If you can get the composition, you can look up the individual components to see if there are any risks associated with them. If I'm dealing in industry, this is one of the sections that I go to right away. In schools, most of the time you guys are dealing with just 1 or 2 chemicals at a time. But again, this is where you'd go to look. Sections 4 through 6 tend to be targeted more at industry, but they are helpful. This is where you're going to find first aid, fire prevention, and spill cleanup information. Okay, definitely helpful to read. It's not where I go first, though. I go to section 2. Now, the next section is section 7. It goes through handling and storage. Section 7 is important. One of the things that I want you to recognize here for methanol specifically is that you really should only use it under a hood. Shouldn't inhale it. Have to keep it away from sources of ignition. So if we have anybody in the audience that is doing the whoosh bottle reaction, or you're doing flame testing and you're using methanol, I'm going to tell you that's a really, both of those are really bad ideas. We've seen a number of accidents and serious injuries all across the US from those 2 reactions. Again, that's the whoosh reaction and the rainbow flame testing. Unless you have the ability to do those under a hood with an explosion barrier between you and the students, you shouldn't be doing those. And even then, it's pretty high risk for teachers. So those are 2 reactions that if I were a teacher in a classroom, I wouldn't do them unless I had an explosion shield. Okay, next one. Section 8. This is the second section that I go to. When I'm doing this for industry and I'm evaluating risk for them, I start with section 2 and then I flip over to section 8. Section 8 is exposure controls. This is a section that's going to have a lot of data in it. It's going to have a lot of words and a lot of abbreviations. So I'm going to teach you the down and dirty Becky's method. Okay, this is just Becky's method. Nobody else. I don't want to blame anybody else if anybody gets upset about this, okay? But this is the method I use, and it's worked pretty darn well for the last 30 years. Okay, you see under that table, we've got all of those abbreviations, TWA, STEL, PEL. Okay, all of those are important, PEL, REL, STEL. All of those are important, but they have a common theme. The lower those numbers, the more dangerous the chemical. So you don't really have to know. It's nice if you take the time to learn what all of those abbreviations mean. But frankly, you don't have to know. What you need to know is, as you're skimming through section 8, if there are chemicals in there that have a listing, if any of those factors are 50 parts per million or lower, 50 or lower, I'm going to say that's a red flag chemical. That's going to go into my bucket of, do I really want this chemical in school? Because this is bad news. This is something that is going to try to kill me right away. and it's very, very dangerous. If I've got any of those factors, any of those abbreviations, and they're 50 to 500 parts per million, 50 to 500 is my yellow zone. Those are yellow flag chemicals. These are chemicals that still present a lot of risk. I really need to think about whether or not I've got all of the appropriate safety precautions in place. And even if I have them all in place, I'm going to have to really think about whether or not this chemical is really useful enough for me to keep it around. Does the risk exceed the utility, or is it more useful and I should keep it around? If I do decide to keep it around, I've got to know how to protect myself and my students from exposures from this one. Anything that's over 500 parts per million, that's in my green zone. Now, I'm not going to like pour it on my cereal and eat it for breakfast. I'm not going to, you know, play around with it, mess around with it. I'm still going to respect the fact that it's a chemical. And the reason that somebody looked into all of these factors is because there is some danger associated with it. But in that green zone, I'm going to be less concerned, and I'm more likely to keep one of those in my inventory. Red zone chemicals, no. Yellow zone, highly unlikely. So if you look at methanol here, methanol is right around 200 parts per million on most of those, whether it's the short-term exposure limit, the permissible exposure limit, the REL, which is the recommended exposure limit. It's right around 200. That throws it right into my yellow zone. I don't know. I'm going to be really thinking about whether or not I actually need this for an experiment. The next section that I go to, so I start with section 2, then I go to section 8. The next section that I go to is section 9. I think this is a critical one, especially for those of us that are scientists. It tells us all of the analytical data that we need to know about this particular chemical. What's the pH of it? Low pH is an acid, high pH is a base. Just how strong is it? Flash point, lower flash point means more vapors, means very, very high level of risk. Okay, lower flash point, more vapors, higher level of risk of a fire. The other thing that I'm going to point out on here, and this is what a lot of my firefighter buddies look for. They look at the UEL and the LEL. Okay, and I haven't covered this a lot in other classes, but I wanted to bring it up with you guys today. The UEL is the upper explosive limit. The LEL is the lower explosive limit. The larger the window is between those two numbers, they're percentages. So for methanol, we're looking at 5.5% by volume for the LEL and 44% by volume for the UEL. That's a huge spread. It's 40% spread of that chemical. What that means is that if we have anywhere between 5% and 44% vapors in the atmosphere, we've just got to add a small spark and we've got a big, big fire. So this, a UEL, LEL spread of this much is considered very high risk. Okay. If you have questions about that, reach out to me. I know that's kind of a confusing concept. More importantly is that flash point. You're going to want to look at that flash point. The lower that flash point is, the more vapors are expanding out into your classroom and the more potential is that they're going to run into something that's going to light them off. So lower flash point is worse. pH on either scale of the spectrum. So 0 to 2 or 12.5 and above, 12.5 to 14. Those are considered the danger areas. And then the last thing that I'm going to bring up here is density. Is it a floater or a sinker? If we've got a density below 1, it's actually going to float on the surface of water. We tend to look at this in emergency response, particularly for things like spills that happen. So it probably isn't going to impact you too much, but I wanted you to understand why that would be on there. And then also in this section, you're going to see that it lists explosive properties and oxidizing properties. Sometimes it will also list peroxide properties. So is this a chemical that'll form peroxides just with sitting on a shelf? Okay, the last section that I look at is section 10, stability and reactivity. This is also critical. So I go section 2, then 8, for toxicology, then 9 for analytics, and 10 for stability and reactivity. And what this does is it gives you an overview of all the different things that the chemical reacts with. For methanol, it's kind of crazy. We've got 36 different chemical classes that methanol gets angry around. We have to be really, really careful if we're storing methanol that we're storing it correctly. Okay, so again, I want y'all to go back and take a look. How much methanol do you have? Are you using it? Do you really need to use it? Is there a better choice? I will tell you that isopropanol doesn't have 36 classes of chemicals it reacts with. All right, it also goes through reactivity on here and stability. Sometimes the peroxide formers are also listed in this section. Okay, and then the last section that I usually use when I'm making determinations about risk is the toxicology information section. I'm gonna be really candid with you. This is a very confusing section. For industrial hygienists, this is great information because it's super in-depth. It usually it classifies things according to different testing techniques. It's very, very technically oriented. The parts of this section that I look at, particularly if I'm going to be working with women or girls that are of reproductive age, is I look at mutagenicity, reproductive toxicity. Those are the big things that I want to know. Is this going to be a problem with germ cell mutagens? Is this going to be acutely toxic? Is this going to cause cancer? All of those different criteria will be listed in this section of the safety data sheet. And you want to look through here, and this just kind of goes through and it's more of a reading exercise to determine how it's classified. All right. This one is tough. There's so many abbreviations. I didn't want to try to tackle that in our short session today, but I did want you to know that it is an important section. So you need to look through it and glean what you can. And this is one of those sections that if you don't understand something in the test results, go back to section 1, call and talk to technical support of the manufacturer and have them explain that to you. Okay. All right, sections 12 through 16, these are also important sections, but I'll let you know they're not really high on my list. The big ones that I look for, again, are 2, 8, 9, 11, and 12. I'm sorry, 10 and 11. 10 and 11. All right, section 12 through 16, these are going to cover things like ecological toxicity. So how bad is this if we end up having a spill outside and it gets in a stream or a river? A lot of times there'll be some high-level basic information on waste disposal, but I will tell you, most of the manufacturers just put in there that you have to dispose of it according to local, state, and federal regulations, and they will not tell you what those are. Again, it's because, just like we talked about a couple of webinars ago, state waste regulations are very difficult because they're different state to state. So it's really critical for you to understand your disposal requirements based on the state that you're in. It does have DOT shipping information, and it's got an other section, and that's just basically their legalese that says if they forgot something that it's not their fault. And this was the best to their knowledge. One of the things that you can do to avoid any of those waste problems is just adopt the nothing down the sink, up the hood, or in the trash philosophy, unless you verify with your regulatory authority that you can dispose of something that way. Otherwise, you need to assume that it is your assumption needs to be that it's on the regulated side. Okay, so this is just kind of an overview of the important things with methanol. So what we saw the pictograms that indicate flammability, acute toxin, and chronic toxin. We've got 3 different toxicity evaluations. TWA, which is the time weighted average over an 8-hour time period, is 200 parts per million. STEL for subcutaneous absorption is 250. Dermal absorption is 250. Well, that's right in that yellow zone. So these are things I'm going to really think about and make a decision that if I decide to go ahead and keep methanol in my classroom, I'm dealing with a chronic and long-term health hazard. It's very flammable, and it's kind of in that yellow zone. Flash point of it is 49.5 degrees Fahrenheit. If it's less than 140, it's considered an EPA hazardous waste. And that's just kind of a trigger for me that says if that flash point is less than 140, that's pretty high risk. I know that those vapors are going to spread all over the place. And then if I look at number 9, the LEL-UEL section 9, that's a very wide window for explosive risk. On section 12 of the safety data sheet for germ cell mutagenicity and reproductive toxicity, it said based on the available data, the classification criteria are not met. Based on the available data. Do I trust those words? Well, how do I know that they actually adequately tested it? I don't know. I got to think about that. And then it lists that there would be damage to liver, kidney, cardiac, irreversible damage of the optic nerve. Ooh, that's bad. And other dangerous properties cannot be excluded. When I see language like that, it tells me that we don't really know just how toxic this is, but we know we've got some problems with it. That's the way that I interpret that type of information. So we know it's highly flammable, highly reactive. We had 36 different categories of chemicals that it reacted with. It's a yellow flag for toxicity. It is acutely toxic for some exposure routes. It's a chronic health hazard. It's kind of unclear about reproductive harm. Students are going to have short-term exposures to this if we're using it in the classroom. Students are going to have short-term exposure, but it could be significant exposure unless we use it under a hood. Teachers might have short-term exposure to it, but you're going to have it time and time again throughout the day. So is this really something that you want to be messing with? More information, the more that you can evaluate and glean out of those safety data sheets, the better decisions you can make on whether or not you're willing to accept that level of risk in your classroom. I'm not telling you no, that methanol should be a forbidden chemical or anything like that. I don't think it's that risky, but I do think it's in that yellow zone, and I think it's something that you all needed to be aware of, because I think a lot of times we just kind of blow off how risky methanol is. One of the things that when you're evaluating toxicity, I want you to also consider that a lot of the data that we have on toxicity has been around for a while. But one of the things that we often don't hear industrial hygienists talk about is, well, what happens if we're exposed to it every day for an entire career? 30 years, 35 years, 40 years. And a lot of times we just don't know because we just don't have the data. So those are things that I'm going to encourage you to think about and minimize your exposure whenever you possibly can for both yourself and your students. All right, so for the next webinar, we're going to talk about your chemical hygiene plan. For both Vermont, New Hampshire, Iowa, for all of the states that are on, you are all required to have a chemical hygiene plan. Sometimes they're called safety plans. For New Hampshire, this is governed by, actually, Department of Education has adopted the OSHA lab, parts of the OSHA lab standard. As of October of 2023, the Department of Education has adopted the requirement that you have a chemical hygiene plan or a chemical safety plan. Okay, we're going to use that name interchangeably. Both chemical hygiene, safety plan, those are used interchangeably. Okay. Even if you are in a state that's not subject, and I think everybody that we've got on these webinars is subject to this. Even if you don't have that, even if you aren't required by law, these are a good idea. The CHP, the Chemical Hygiene Plan, pulls together several OSHA requirements. And it gives you the opportunity to really look at your inventories, make sure that everything that's on the inventory for the school is stuff that you want in the school, that you've adequately evaluated the risk for, and that you have safety measures in place to minimize risk and exposure to students and staff. We're going to discuss the components of the chemical hygiene plan. I'm going to give you some examples of some different things, and I'm hoping before then to have some of those chemical hygiene plan examples up on the Hazardous Materials Consulting website. No promises, I'm really working hard on it, but it's taken a little while to get it pulled together. Okay. So as you're going through all this, as you're identifying things that we're going to also have in your chemical hygiene plan, remember RAMP, developed by the American Chemical Society. We want to recognize, assess, minimize, and prepare. To prepare most for your chemical hygiene plan, I'd like you to look at your lab procedures and your inventories, make sure they're accurate, because those are going to be part of a safety plan or a chemical hygiene plan. Include in those, in your lab notes or your lesson plans, the safety strategies that you need, that need to be implemented to protect students and you from exposures and risk. And then I would also encourage you in those lesson plans to include a section on waste disposal. Identify which are the chemicals that you're going to have to collect and manage as hazardous waste, and then work with your safety team, your chemical hygiene team, to identify what is your safety or what is your disposal strategy going to be. And then I think that's, and then so we want to include the waste disposal section in your plans. And then for webinar number 6, we're going to go through that chemical hygiene plan. All right. That's all I've got for today. So do we have more questions? Please feel free to ask any questions. All right. If we don't have any more questions for today, I just want to tell you all, I really appreciate the fact that you take the time out of your schedule today. I know that's really hard to do. And if there are things that as you're working through these processes, because I know these can be very overwhelming, developing an inventory can be very overwhelming. Assessing the risk, whether or not a chemical is worth it, and looking at that safety data sheet, I know that can be also very difficult. And then building that chemical hygiene plan and the team, maybe even that should be on that chemical hygiene plan or safety team. All of those are really tough. And I've worked with schools all throughout the country as they've gone through these, challenges to try to up their safety programs even more. And I know you're all tasked with 10 more jobs than you should have. If there are any questions that you have, if there are any resources that you need, even if you want to send over, 5 or 6 chemicals that you're kind of on the fence about, you're welcome to send those over to me and I can help you work through whether or not those chemicals are too risky for your classroom or they're manageable and you should be able to go ahead and keep them. So please, know that you have resources available to you as you're trying to maneuver through this. Okay, anybody else? Thanks, Heidi. Good to see you on here today.
Thanks so much, Becky.
Okay, thanks you guys.